So this tutorial talks about IP addresses and particularly what we mean by an IP subnet. So up here we have an IP address in the format we normally write it in, 132.235.201.195. It's one of the addresses we use in the Internet Engineering Lab, the Internet Teaching Lab at OU. Over here is what internally the computer will see. That's the binary representation for that same address. So the question every device on the internet has to deal with is, does this address belong to one or more subnets for routing purposes, or determine whether it's a local address, those sorts of things. So originally subnets were fixed. This address here, 132.235, and anything following it, was considered part of a Class B address, which today we would call a /16. Both of those notations mean that the first 16 bits of these 32 bits total define the subnet that address is in. And for convenience, this particular address for Ohio University is still considered a /16 in the internet today. So let's figure out what that really means. It says that the first 16 bits of the address do describe the subnet. When it designate that here, the way we do that in the internet by writing down a 1 bit for every bit that designates a subnet, and a 0 for everything else. Let's do that here. So we're going to do this in blocks of 8, in octets. So the first octet, of course, has to be all ones. And the next one has to be all ones. That's 8 plus 8, 16 bits. That's how many we wanted for our subnet, so we're going to set the rest of them to 0. That is a /16. And in the older notation, we write this the same way we write an address, just converting it again to decimal. And so this would be a 255.255.0.0 network mask, or a /16 subnet. So this address is in what subnet, if we assume it's a /16? What this notation helps us decide is that out of these 32 bits, to figure out what the network is, the subnetwork, we copy the bit down if there's a 1, and we don't copy, we fit on a 0 if there's a 0 in the mask. So let's do that. So for the first octet, we're supposed to copy all the bits the same way they are in the address. So let's do that. Now here we have zeros, so we're supposed to just fill this with zeros. So the network that this address is in is 132.235.0.0. Now in today's networks, an address can be in one of many subnets, and each device can be told to divide all the addresses that are in the internet into different subnets. And different devices will look at the address a different way. For example, at Ohio University, when the first device at Ohio University sees this address, it is told that this and many other addresses are part of networks under a /24 network mask. Now our mask here is a 16, 8 plus 8. So we need another 8 to make 24 bits. So let's do that. So now this is a 24. 255.255.255.0. And of course what we have down here is no longer right, still need to copy these 8. We still need to copy these 8. But now we need to copy these 8 as well. So let's do that. So now for this new device, thinking of networks as /24s, this address is part of the 132.235.201.0 network. And when we work in the Internet Teaching Lab and we set up devices, we'll actually make networks even smaller. Let's say we tell you that we want you to use a /28 network, not a 24, but a 28. That means over here we're going to have to set 4 more bits. Let's do that. Okay, so now that's a 28. So that's the first mask we've seen that has something other than 255 and zeros in it. 255.255.255.240. That's this number here converted to decimal. Now, of course, we've got to correct down here. So this is right, copied everything down. This is right, copied everything down. This is right. Here, we've got to copy the first 4 bits of the original address over here. So let's do that. And the last 4 bits, of course, we zero out because we're not supposed to copy them. So in the lab, assuming we considered /28 subnets, this address here, the one we started with, is now in the network 132.235.201.192. In most cases, what we want to do is compare addresses, figure out if they're in the same network. And the way to do that, of course, is to take an address and figure out what network it is in, and any other address that starts with the same bits will come back with the same network number and is therefore in the same address. So that completes this short tutorial, and in future ones we'll look at how to actually lay out subnetworks.